So let's actually plot the distance time graph of an object under free fall. We saw the simulation. Let's actually do it. Let's see what happens every second as and when an object falls. So the main aim over here is to calculate and plot the distance traveled by an object under free fall every second. So let me add that. So we're not going to calculate throughout, obviously, per second is what we are aiming at. So first thing is the free body diagram. Object, we're going to consider a scenario wherein u is equal to 0 meter per second and it's under the influence of gravity only. And this is for time t is equal to 0, right? So here is where we'll start our calculation. So the first thing is t is equal to 0. Remember, acceleration, that is g in this case, acceleration due to gravity, acceleration due to gravity, Earth's gravity to be specific. It's approximately equal to 10 meter per second square. Okay guys, so this is one thing that you guys have to keep in mind. So acceleration, if someone tells an object is falling near the surface of the earth, you guys have to take the acceleration to be 10. Okay, so let's see what happens at 0 second. It's 0, right? Because time is 0, so the distance traveled by the object is 0. Now, next thing is case within a second, what happens? Well, s will be equal to u is 0, so ut will be 0 plus half, right, a t square 1 square, so this will be 5. So s will be equal to 5 meters, right guys? So just a second, I would like to have this information as well. Anything down is positive, so let me mention this as well. So we are taking anything moving down is positive, so your direction of acceleration will be down and it's equal to g, right? I think, yeah, this is good enough. Okay, next thing is for t is equal to 2 seconds, case for t is equal to 2 seconds, s is equal to, here to ut is 0, so half acceleration into 2 square, so that is 4. This is 20 meters. Now case 3, not case, yeah, case 3 only, case 2, 3, 4, or t is equal to 3 seconds. Here to ut will be 0, so I'm not taking that. This will be 9, so this will be 45 meters. Can you see the gap? Here the difference is 15, here the difference is 25. So you keep doing this. Case t is equal to 4. So s is equal to half into 10 into 16. So this is 80, right? 80. And here the difference here is 35. So the gap is increasing. Okay, so let's see if we have enough information to plot what we require. So for t is equal to 0, distance is 0, and for t is equal to 1, that is within 1 second it has traveled 5 meters, then 20, 45, 80. 20, 45, 80, 2 and 3, right? So I have velocity and acceleration also. Throughout the acceleration will be 10, right? Velocity, all of this calculation, it's too much. So what I've done is, yes, I have a program which will help us figure this out. So you can see g, I kept it as 10 meter per second square. Then we have half time of flight and all of that. So this is where is it? Calculation is happening over here. Can you see this, guys? It's over here, ut plus half at square. Okay, everything else is a bit messy for you guys. You won't be able to understand. I mean, it's done neatly, but it looks messy. You won't be able to understand most of it. So this is a program wherein we're going to we're going to tabulate the values. So we're going to put it in an Excel sheet. Okay guys, so I need to close it for it to work. So we're going to, now you don't see any values. So once we simulate this, right, we'll have values in that particular file. So enter at what distance the object is in. So We done it till what? 80 meters now. I'll just show you guys 80 meters. Let's see what happens. Considering the acceleration due to gravity to be 10 meter per second square. Okay guys, so that is one thing. So let me just, it will look better. Let me remove the gap. Yeah. Okay, so let me open the file now, just a second. Okay, and these are your values. Can you see that? 0, 5, 20, 45, 80, and the fifth second is 125. Okay guys, so 5 is equal to, at fifth second it is 125. 0, 1, 2. Did I mess up copying? 520. Oh yeah, I messed up copying. This is 520. Then 45. 80 is the fourth second. And fifth second is 125. And the velocity turns out to be 0, 10, 20, 30, right? Because the acceleration is 10. Obviously, the velocity will also increase in values of tens. Okay, here we are planning to draw distance versus time graph. And we are taking a scale of per second basis, right? Along the x-axis, it's per second basis. Along the y-axis, the highest value is 125. I think 10, 20, 30, 40, 50, 60, 70, 80, 90, 20. Yeah, 10. So this is 0. Along this, we have our time in second. And this is distance in meters. Right, guys? So you can see that table has all of that. Sorry, I didn't talk about the table. So we have time, distance, velocity in meter per second, and acceleration in meter per second square. Time is in seconds and distance is in meters. Right, guys? And we are plotting from 0 to fifth second. Right? The calculation will run the same. It's not too hard. So now let's actually we need to write the values for, or let me give a gap of, yeah. So every 2 ticks, right, we have a second. So this will be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, exactly what we wanted. That's good. So let's start plotting. At 0 second, it's 0. First second it is 5, so 5 is somewhere over there. 2 it is 20, it's over there. 3 it's 45. 4 it's 80. And 5 is 125, somewhere over there. And we have the graph looking like this. You see that it's an exponential growth. Okay, I could have done a better job by bending it a bit, but anyways. And we can write the scale as well. Scale x-axis, every centimeter has half a second. And y-axis, every centimeter is 10 meters. So can you see that for 5 seconds, we have to go to a height of 125. And I need to have a camera which zooms in, and it's not easy. That's why I simulated. Okay, guys. Again, you need to understand all of it in a right manner. What I mean to say is you need to link this topic to the previous topic. You need to understand that this is an accelerated motion. You need to understand that this is a distance time graph. So here in maths, what you learn is how to plot a graph, the standard of plotting a graph. You need to have a title, you need to have a scale, you need to have the x and y axis mentioned, right? X and y axis and the origin mentioned, and marking all the texts and marking the values, right? So this is your object under free fall, naming the graph. If there are too many, they generally name the graph. If not, in the title, they mention distance time graph of a free falling object. I don't have space, so I can write it over here. So such discipline is what you have to learn. Everything is interconnected. Clear you can see, and you guys know it's not something out there. Is it not? So this is your distance time graph of an object under free fall. But yes, I'm not just ending over here. When we have a simulated version and we have a program which can help us do weird stuff, why not throw the ball from different places? Okay, let's do that. So here we're going to see how long will it take for an object to fall from a height of 182, 828 and 8849. Those values, you understand what are those? So let me kind of erase this off. This is okay. Yeah, let me go back to this. Yeah, let's simulate the distance. First distance is what? First distance is, okay, we are dropping a ball from Sardar Vallabhbhai Patel's statue, right? So we are going to the statue, standing at the top of it, right? We got a space wherein it can directly fall to the ground. So it is 1825 meters above the ground. So let's see how long will it ball take for it to fall. So it is 182, right? So many meters up the ground, and we have 18. It almost takes 6 seconds. That's it. So that's a huge thing. It takes only 6 seconds for the object to fall, right? So you can see at 7 seconds it's 245. Now let's drop it from where is it? Let's drop it from Burj Khalifa. So 828. So let's see how long it will take. 828. These are all supposedly near the surface of the earth, not far away. What do you guys guess? How long will it take? 828, almost 12 seconds. Not 12, sorry, almost 13 seconds. Just 13 seconds from such a huge building. You know? Think about a lift. 13 seconds, does it go top? It's supposedly fast. I don't know if it goes to the top in 30 seconds. You guys can web search that. And last is, yes, we have the top of Sagarmatha. That is your Mount Everest. Okay, so from the top of the Everest, let's see what happens. How long will it take? Any guesses? Will it take more than a minute? What do you guys think? So it is 8848. As of today, it is 884849. Okay, let me 49. Make your guess. You guys can pause and think over. Don't calculate, make a guess. You guys have your guess. Does it take more than a minute or less than a minute? That's all. Let's see. And the answer is, it takes less than a minute. Just 42 seconds. Or 43 seconds. Think about it. From such a top of the world and all of that, it just takes 43 seconds to fall off. If we go there and if we happen to drop off and there's nothing to stop us, there's no mountain. It's like Mount Everest was something like this. You guys dropped, and if it was something like this, and if this was the top, imagine that you guys have a ball. If you guys drop it, or a mic, if you drop it, it just takes 43 seconds. That's it. Right? So all of this is possible if you understand the syllabus, if you understand the concept, and if you're able to, just simple coding. It's not a complicated one. Whatever you're saying, it's very simple coding. Okay, guys. But yes, you're going to make use of such a technology to help you guys figure out some weird shit. You guys can think and go beyond your books. Right? You can quest your curiosities. That's what I feel you guys should be doing. Don't take it as just a subject, right? Of course, if you guys think about what will happen if you jump off, there's an anime wherein there's a character wherein he pushes himself from the moon and all of that, and he jumps towards the earth. So if you guys can think about it, how long he takes from here to here, right? So you guys can it's a bit of physics, bit of calculation. So you guys can figure out like what is the force with which he should have pushed so that he will be reaching over here and all of that. Or if you can think of, there was a company which had a skydiver. I think, yeah, skydiver, right? Almost near one of the highest possible height he had jumped from without a parachute or something like that. Even that you guys can calculate how long that would a person would have taken, and in actuality how long he took and all of that, and why is the reason. Answer won't match a bit. Why is that? You guys can figure out that. It will lead to further understanding of the concept. Okay guys, so I hope you guys enjoyed this, and yes, all of this will be available to you guys so that you guys can also simulate and do weird things and try to understand the concept a bit better. Okay, so please pause, have a look at what we have done. Oh, I should have written the answers over here. This is around 43. This is around, we just did that. I think 6 seconds, 6 or 7. I think 7, right? And this I forgot. 13. Anyways, you guys can do it on your own as well.